Students, happy day. In today's class, we are going to continue with the next topic of the chapter areas related to circles. The next topic is very easy, areas of combinations of plane figures. Hope you remember what we have learned so far in this chapter. We have seen the basic things related to the circles like circumference, area, chord, segment, sector, right? And in the previous topic, we have seen how to find the area of a sector and a segment. Keeping all these in our mind, we are going to solve our next exercise. To solve this exercise, it doesn't need any special explanation or a special formula to be remembered, because this is areas of combinations of plane figures. We will be having several plane figures. We have to manipulate it properly to find the required area or to find the area which is mentioned in the question. Okay, so if we solve problems, it will be clear for you. Let us move on to the exercise directly. Now we are in the first question. Find the area of the shaded region in figure 12.19 if PQ is 24 and PR is 7 centimeter. Okay, and O is the center of the circle. So they asked you to find the area of this shaded region, and see they have drawn a line. PR is not the arc length. PR is a line segment. There is a triangle, right? So they have given you the measurement of PQ and PR, and O is the center of the circle. They asked you to find the area of this shaded region. So how can we find the area of this shaded region? See, area of the shaded region will be area of a semicircle minus area of the triangle PQR. So area of this semicircle minus this triangle will give you the area of the shaded region. Yes, how to find the area of this shaded region? Area of this full semicircle minus this triangle will give you the shaded region. So what is the area of this semicircle? Area of circle is pi r squared. Area of semicircle is going to be half pi r square, right? So for that we need what is the radius. Whether radius measurement is given in the question? No, right? They have given you what is PQ and what is PR. So only if we know what is OQ or OR, because O is the center, we can find the area of this semicircle, right? And moreover, if you see triangle PQR, and P is the angle in a semicircle, because this is center. Angle in a semicircle, we know it is 90 degree, right? Therefore, angle P is 90 degree, and hence triangle PRQ is the right triangle. We know two sides of a right triangles. Therefore, by using Pythagoras theorem, we can find the third side of a right triangle RQ. RQ square is equals to PR square plus PQ square. So, if we substitute, we found RQ as 25. If RQ is 25, what will be OQ or RO? RQ is the diameter since it passes through the center. Therefore, radius is going to be half of that, right? So, 25 by 2. I told you many times, whenever you have further simplification or further calculation in your problem, don't simplify it to the core or don't make it as a decimal. If you keep it in fraction, your calculations will become easier. So, that's why I kept it as 25 by 2. Now, let us get back to our area of shaded region. So, area of semicircle minus area of triangle PRQ. Area of semicircle is half pi r square minus area of triangle is half into base into height. Since it's a right triangle, the perpendicular distance is going to be the height. So, height is 24 and base is 7. Right, and R is 25 by 2 we found already, and in the beginning of this exercise they asked you to use pi as 22 by 7, so I have used 22 by 7. Then cancel it, simplify, we will get our answer, right? Hope you got it. It's very easy. It all depends on how you analyze the figure which is given in the question, right? Now let us move on to the second question now. Now the question is, find the area of the shaded region in figure 12.20 if radii of two concentric circles with center O are 7 cm and 14 cm respectively, and angle AOC is 40 degree. So it's very clearly given. They asked you to find this area. How to find this area? Area of this full sector minus area of this small sector will give you this area, right? Area of this full sector AOC, this full sector minus area of this smaller sector will give you this remaining area. So what is area of a sector formula? Area of a sector formula is, always sector is named with the 4 vertices. So have one point on the arc and then name it, right? What is area of a sector formula? Area of a sector is theta by 360 into pi r square is the area of the sector formula. So to substitute in this formula, we need to know what is theta and what is r. Theta, the angle made by the radii at the center, which is given in the question, and the radius for the bigger sector, the bigger circle radius is 14 and smaller circle radius is 7. Both the radius are given. So we can easily solve this problem, right? Hope you can solve this problem. Let us move on to the third question now. Now the question is, find the area of the shaded region in figure 12.21. We have to find this area and this area. If ABCD is a square of side 14 cm, APD and BPC are semicircles. So it is very clearly given. Those two are semicircles and it is a square with side 14 cm. So how to find this, the shaded region? Area of this full square minus area of these two semicircles. What is area of a semicircle formula? 1 by 2 pi r square, because pi r square is the area of the circle. Semicircle means 1 by 2 pi r square. But we have two semicircles here. So 2 times 1 by 2 pi r square. Why we made it as 2 times? Because both the semicircle is of the same measurement only, with the same radius, right? So to find the area of a semicircle, we need to know what is its radius. So for that they have given you the side is 14, which is the diameter of the semicircle. So radius is going to be 14 divided by 2, which is 7. So using that we can find the area of a semicircle, and area of a square formula is a square, right? Hope you got it. Area of the shaded region is area of a square minus area of two semicircles. Area of a square formula is side square, which is 14 square, minus 2 times 1 by 2 pi r square. Radius is going to be 14 divided by 2, right? Hope you got it. Let us move on to the next question. We are in fourth question now. Find the area of the shaded region in figure 12.22 where a circular arc of radius 6 cm has been drawn with vertex O of an equilateral triangle of side 12 cm as center, right? So what is given? A circular arc is being drawn of radius 6 cm. They asked you to find the shaded region. So if you see the shaded region, you should not get this overlapping area, okay? It is not given, it's a circle, it is an arc is being drawn. So we have to eliminate this sector region. We have to eliminate the sector region from the circle. Then we have to add the area of the circle and the area of the triangle. I repeat, what is the area of the shaded region? Area of the circle plus area of the triangle, but not area of the entire circle. From the area of the circle, we have to omit this sector region because that is included in the triangle, that is not included in the circle. Only once we have to add that, right? Since we know the formula to find the area of a sector, we can omit it from the circle rather than omitting it from the triangle, because it will become tedious if we omit it from the triangle, right? So how can we find the area of the shaded region here? Area of a circle minus area of this sector plus area of this equilateral triangle. right? So what is area of a circle formula? Pi r square. We need to know the radius. Radius is given in the question. Area of a sector is theta by 360 into pi r square. So we have to find the area of this sector. We have to omit this, right? So what is this angle? What is this angle? This angle is 60 degree. Why? Because triangle OAB is a equilateral triangle. In an equilateral triangle, we know each angle is 60 degree. Therefore, this is 60 degree. And we know what is the radius. So, we can very well find the area of the sector. Plus, what is area of an equilateral triangle formula? Root 3 by 4 a square. What is the side? Side is 12 centimeter. Right? We can substitute. And if you simplify, we will get the area of the shaded region. Yes, hope you got it. Let us move on to the next question now. Now we are in the fifth question. From each corner of a square of side 4 centimeter of a quadrant of circle radius 1 centimeter is cut, and also a circle of diameter 2 centimeter is cut as shown in figure 12.23. Find the area of the remaining portion. I repeat, from each corner of a square of side 4 centimeter, a quadrant of circle radius 1 centimeter is cut, and also a circle of dia 2 centimeter is cut. Find the area of the remaining portion. So it's very easy again. So from the area of the square, we have to omit or delete the area of these 4 quadrants and also the area of this circle. If we delete all these areas, we will get the area of the remaining region. Right? So how to find the area of a square? Square is side square. We know the side is 4 centimeter. And what is area of the 4 quadrants? Why we made it as 4 quadrants directly? Because all the 4 quadrants are of the same measurement. We know area of a circle is pi r square. Quadrant is going to be 1 by 4 pi r square. So 4 times 1 by 4 pi r square. So these two 4's will get cancelled. We need the radius for that. Radius is 1 centimeter, which is given in the question. Don't get confused with the side of a square and the radius of the quadrant. Then what is area of a circle? Area of a circle is pi r square, and dia is 2 centimeter. Therefore, radius is going to be 1 centimeter. If you substitute in the formula, we can easily arrive at the answer. Alright. Hope you got it. Let us move on to the next question now. We are in the sixth question. In a circular table cover of radius 32 centimeter, a design is formed leaving an equilateral triangle ABC in the middle. Find the area of the design. So we need to find this remaining area. So we have to find the area of this design. How can we do it? Again, this design area can be found by eliminating this area of this equilateral triangle from the area of the circle. We know area of a circle formula is pi r square. For that we need the radius, which is clearly given in the question. But what is area of equilateral triangle? Root 3 by 4 a square. For that we need to know what is the side of the equilateral triangle. Right? Only if we know the side of the equilateral triangle, we can go with that formula. Or else we should know what is base and the height. Right? Then only we can go with half into base into height. But as far as this problem is concerned, they have given you only the radius. They didn't talk about any of the side of the triangle. So if we find the side of a triangle, we can very well solve the problem. So let us see how can we find the side of a triangle. Now see, what is the beauty of an equilateral triangle? Equilateral triangle, the median and the altitude will coincide each other. Hope you all remember, we have learnt this in our class 9. In an equilateral triangle, all the medians and the altitudes will coincide each other, and also we know the meeting point of the medians is centroid. Centroid will divide the median in the ratio 2:1. We'll divide the ratio in 2:1, right? Now let us draw a median AD of triangle ABC, and we know O is the center, and which is going to be the centroid of the triangle ABC. And we know centroid will divide the median in the ratio 2:1. In the ratio 2:1. Centroid is the meeting point of the medians, right? Therefore, AO by OD is equals to 2 by 1. But what is AO? Since O is the center of the circle, AO is the radius. Radius is 32, which is given in the question. So 32 divided by OD is equals to 2 divided by 1. From this we can find what is OD. Right? We can find what is OD. Therefore, AD is going to be 32 plus 16. So we got the AD measurement as 48. But using the height, how can we find the side of the equilateral triangle? This is, and one more thing, just now I told you, in an equilateral triangle, the median and the altitude will coincide each other. So hence this AD median will act also as an altitude. What do you know about altitude? Altitude is perpendicular. And hence this triangle is a what? A right triangle. Right? Right triangle. How can we find the other side using right triangle? We can go with Pythagoras theorem. So what do you know about Pythagoras theorem? Hypotenuse square is equals to sum of the squares of the other two sides. So AB square is equal to AD square plus BD square. But BD can be written as BC divided by 2. Why? Because D is the midpoint. Because AD is the median. D is the midpoint. So BD can be written as BC divided by 2. But we don't know none of the sides of an equilateral triangle. If we have two unknown, we cannot solve this problem. So what are we going to do is we are going to replace BC by AB itself. Because BC is also a side of an equilateral triangle. AB is also the side of an equilateral triangle. We know all the three sides are equal. So substitute BC as AB. Now bring AB to one side and numbers to the other side. Take LCM and simplify it. We have square on both sides. So if we take square root, this will become root 3 AB divided by 2 is equal to 48. Right? So AB is equal to 48 into 2 by root 3. 48 can be written as 3 into 16 into 2. Why we have written 3 into? Because we can cancel root 3 with 3. So we got AB as 16 into 2 into root 3, which is 32 root 3. Now we got the side of an equilateral triangle. So we can very well substitute in this formula. We got what is our A and what is our radius. So we can substitute and find our answer. I repeat what we did here. We need to know the side of an equilateral triangle. How to find the side of a triangle, equilateral triangle, without knowing anything about the triangle? Only the radius we know, right? And we know the beauty of an equilateral triangle is all the medians and the altitudes coincide each other. And also we know the centroid will divide the median in the ratio 2:1. Using these two concepts only, we are going to find the side of an equilateral triangle. First, we have applied the centroid property and we found what is AD, and then we told since median coincide with the altitude, this angle will be 90 degree. Therefore, by Pythagoras theorem, we can find what is our AB. Again, while applying Pythagoras theorem, we have applied the property of equilateral triangle that all the three sides are equal. Therefore, instead of BC, we have replaced it as AB. Right, and then we found what is our AB. Then we can substitute in the formula to get our answer. Right, I hope you got it. Now let us move on to the next question now. Now we are in the 7th question. ABCD is a square of side 14 centimeter. With the centers ABCD, 4 circles are drawn such that each circle touch externally 2 of the remaining 3 circles. Find the area of the shaded region. So we have to find the area of this shaded region. It is given it is a square of side 14 centimeter. Again, it is clear how to get the shaded region. Area of the square, we have to subtract the area of these 4 quadrants. Right? How can we find this? This will become the radius, right? The side is 14 centimeter. So the radius is going to be 7 centimeter. And what about the angle? To find the area of the sector or a quadrant, we cannot take it as a quadrant, or you can take it as a sector, right? So what is to find the area of a sector, what is the formula? Theta by 360 into pi r square. What is the theta? Theta is going to be 90 degree because it is a square. So from the area of the square, if we subtract the area of these four sectors, we can get the remaining area, right? Or else you can directly go with quadrant also, 4 times the area of the quadrant. It all depends on you. But the radius measurement is 7 centimeter because the side is 14. Yes, hope you got it. Let us move on to the 8th question now. See, figure 12.26 depicts a racing track whose left and right ends are semicircles. The distance between two inner parallel line segments is 60 meter. What it is? The distance between two inner parallel line segments is 60 meter. So the distance between this line and this line, this distance is 60 meter, and they are 106 meter long. This is 106 meter. Right? If the track is 10 meter wide, which means this distance is 10 meter, find the distance around the track along its inner edge. Obviously, the distance which you measure from the inner edge will differ from the outer edge. Yes? So, they asked you to find the distance along its inner edge and the area of the track. The question may look tedious, but when you analyze it, understand it properly, we can solve it easily. So let us see how can we solve this problem now. These are all the things which is given in the question, right? The length is 106 and the width of the track is 10 meter and the distance between the parallel lines is 60 meter, and they have given you both the ends are semicircle. So we are going to divide this track into two shapes, semicircles and the rectangles, right? Now they asked you to find the distance around the track along its inner edge. So how can we calculate this? GL plus perimeter of this arc or the circumference of this semicircle LKJ and IJ, and then inner circle circumference of this semicircle. And we know clearly this is 106, this is also 106. So 106 plus 106, we got it. What is a perimeter of a circle? 2 pi r, but this is semicircle, right? So half into 2 pi r, right? Half into 2 pi r. Now how will you find the radius of this? See, this distance is 60 meters. So it clearly shows this dia is 60. So what will be the radius? Radius is going to be 60 divided by 2, right? 60 divided by 2 will give your radius. So we got our radius, so we can very well find the circumference, perimeter of this inner semicircle. So 2 times we have to add. Then if you simplify, we will get the distance around the track along its inner edge. So what we did, this distance plus this distance plus this semicircle plus this semicircle. That too only the circumference, not the area, right? Hope you got it. The second one is area of the track they asked, which means this shaded region we have to find. How to find the area of the shaded region? We have divided it into two triangles, right? So it can be found by area of this triangular region plus area of the circular path plus area of this triangle path plus area of this circular path. So it is enough if we find once the area of this rectangular path and the area of this circular path, then we can multiply it twice because the measurements are going to be same. How to find the area of this circular path first? How to find the area of the circular path? See, this area we need. How can we find this shaded area? The area of this bigger semicircle BDC, the area of this bigger semicircle BDC minus area of the smaller semicircle LKJ will give you this area of the shaded region. I repeat, area of this bigger semicircle BCD minus area of this smaller semicircle will give you the area of this shaded region. What is area of a semicircle formula? 1 by 2 pi r squared. So how will you find the radius of this bigger circle? What is the dia of the bigger circle? See, this distance is 60, right? This distance is 60. 60 plus 10 plus 10. 60, 70, 80 is the dia of the bigger circle. 80 is the dia of the bigger circle. So what will be its radius? 80 divided by 2, which is 40, right? What is the radius of the inner semicircle? Again, the dia is 60, therefore radius is going to be 60 divided by 2, which is 30, right? So if you simplify, you will get the answer. Hope you got it. How to find the radius of the bigger circle? The dia, this is 60, 60 plus 10 plus 10. So this will give you the dia, which is 80. Therefore radius is going to be 80 divided by 2. So we can obtain the area of this circular path once. So if we multiply it to 2, we can find the area of the circular path twice. Now how to find the area of this rectangular path? Area of the rectangular path is length into breadth. Length is 106, breadth is 10 meter, which is given. So 106 into 10 will give you the area of this rectangular path once. But we need it twice, so we have to multiply it by 2. So if we add all the 4 areas, we will get the area of the shaded region. See, area of the shaded region is twice area of circular path plus rectangular path. I have written 2 as common, or else you can write separately and then you can simplify. Yes, hope you got it. So with this, let us wind up today's class. So this topic is very easy because nothing new we learned here. All what we know already we have just applied. So if you are thorough with the formula and if you can analyze the question properly, you can get the answer easily. So do exercise 12.3 question number 1 to 8 as your homework and post it in the group. If you have doubts, you can ask me. Thank you, students.